Thank you for visiting this video, everyone. We're going to talk about visitors. In a nutshell, what visitors do is they allow you to add logic to classes, to a class structure, without actually modifying those classes themselves. We'll jump right into an example. Let's say we got a payment source protocol. So this is a protocol is like an interface if you're not familiar with Swift syntax or Swift language. So payment source will just basically be something that we can make a payment from. So let's say that it has an ID and it has a balance in cents, which is just how much money is in this payment source. So we'll make a concrete implementation of it here. So let's do a bank account. So it'll have an ID. This will be a struct. And a balance. And just to make this example a little more complex, we'll add a couple other concrete implementations here. So I'll add a credit card. And just to be crazy here, we'll add a Bitcoin wallet. Just gotta hop on that crypto train. All right. So let's say for each concrete implementation of this payment source here, we want to make a payment with one of these, with each of these. So for example, let's say we got a bank API that we're going to hit and say, I'm going to make a payment of $100 from this bank. And then same thing with credit card. You know, maybe we have a credit card service we're hitting. Same thing with Bitcoin. Let's say we have a Bitcoin API that we're going to be hitting to pay off, just to make a payment with Bitcoin. So kind of the first thing that comes to mind how you'd implement this is you could have add a function here, you know, make payment, blah, 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 that'll do hit the payment API. You can do kind of similar logic for each of these. I guess the problem with this, usually these implementations here are referred to as models, which means that typically you want models to be dumb and just kind of store information. So, and not worry about, you know, not make network calls or not worry about more implementation detail, but you want them to be just distinct units of data that are dumb. So instead of adding that logic to these models, you could, you know, make some sort of helper method here and some other class, I don't know, helper class that takes in a make payment, that takes in, you know, a payment source. Take that in there, and then, you know, the amount of cents that you want to actually make for the payment. And then within this method, we could do a switch here on payment source. And if it's case so if it's a bank account, then we would make a call to bank API. If it's a credit card, oops. This is just basically doing a type check. So it's checking the class type here. And based on the class type, it's deciding which API to make. And like this could, for example, be credit card API. Make payment, blah, blah, blah. And this could be bank. You get the idea. And then same with Bitcoin here. All right, so what's the problem with this approach? So this will work. Typically, you want to avoid making switch statements on class type. instead of switching on the class type yourself, make the compiler switch on the class type. And the way you do that is using polymorphism. Because, for example, one problem here is, what if we down the road want to add another, what if down the road we want to add another payment source like Venmo, Venmo payment source, blah, blah, blah. That would mean that every time we do a switch on payment source in our code, we need to look at it and then add another case statement to handle the Venmo payment source. You can do that. You'll just have to search through your code for all those cases. It would be much better if you would just get a compiler error anytime you start supporting a new payment source. Much safer. And then just another point is, it just kind of bloats the code if you're doing switch statements on class types, especially if you're supporting a lot of different concrete implementations of payment source, as an example. But you don't want massive switch statements everywhere. So how do we solve this? The answer, you'll never guess. It's the visitor pattern. So let's step back here and try to implement this type of logic with the visitor pattern. So the first thing you do when you're doing a visitor pattern is you make the visitor protocol. And what we're going to be doing is visiting each concrete implementation of payment source. So this is going to be the payment source visitor. So what you do is you define a function for each concrete implementation you're visiting. So we're visiting visit bank account, visit credit card, and then visit Bitcoin wallet. Okay. And then we're going to make a concrete implementation of the visitor that does a unit of work on each of these concrete implementations. So for the example we're going for, we want to make a payment to an API. So we'll create a I remember I wanted to make this a class for some reason, I forget. But so we'll call this just a make payment source visitor. Kind of an awkward name, but whatever. Payment source visitor. All right. And what this visitor is going to do is, for each of these concrete implementations, it's going to add an action specific to that concrete type. So in other words, it's going to call the API to make a payment for bank account, for credit card, and for Bitcoin wallet. All right, so we got our visitor defined. We got a concrete implementation here. We'll flesh these methods out in a bit. But first we got to actually allow the payment source to be visited by the visitor. So we'll add this function here. So it's got to accept, and I know this is if this is your first time looking at the visitor pattern, you might be wondering, how is this all going to connect? I'll give you an example of this being written, but it's a little confusing right now. So this will accept a payment source visitor. Accept visitor, payment source visitor, and then each of these guys have to implement this. Visitor dot visit bank account. So I'll add this visit method to each of these. Again, this might be a little, unclear how this is going to work end to end, but I'll clear it up in just a sec. So credit card. And then Bitcoin wallet. All right. I'll just move these guys down here. Okay. All right, so basically how this is going to work is whenever we have a payment source, we can call this accept visitor method, and then that will trigger on each of these concrete implementations, it'll pass itself into the visitor, and then the visitor will have a reference to the model that it wants to use. So let's just kind of stub these out for a sec. Make API call to make bank payment. That's what this will eventually do. Make API call to make credit card payment. Make API call to make Bitcoin payment. All right. And what this will look like, I'll just make a kind of function to demonstrate this. This is what this will look like in actual implementation here. So let's say we have a payment source. Payment source, and we'll make it a bank account. So bank account with an ID, and then bank account will have $1, 100 cents. So how will the payment get made? How will it look like in code? So what you'll do is you'll actually first we'll make a visitor here. We'll make that a make payment source visitor. Terrible name. And the payment source will accept the visitor. All right. So we make an instance of the visitor here. Payment source will accept the visitor. And in this case, the payment source is I'll just kind of make this a little more clear here. So it's a bank account. So what will happen is this method is called here. Oh, oops. It's called here. The visitor, which is a make payment source visitor, will have this method called passing in the bank account here. And then this is where we'll make the API call to the bank API, let's say we got a bank account API here, make payment with ID, bank account ID, and then amount. So we haven't actually specified the amount yet, so let's make that say we want to pay 50 cents here. So the amount will be passed in here. And then you can imagine the other calls will be similar here. For this one, it'll be, credit card API. And then this will be Bitcoin API. All right. So this is a little bit of a contrived example, but let's use an example that maybe is one you've seen before in your code. Let's say we have a function here. Make payment. Where you get a payment source. Okay. And then let's get rid of this. And we'll call this make payment function from the main method here. Bank account. So within the scope of this method, we don't know that it's a bank account that we're passing in. We just know it's a payment source. So what would the, this is something you might see people doing if they're not aware of this design pattern. They'll do a switch statement, kind of what we showed before, where you check to see if, is the payment source a bank account, and then switch between the other cases, blah, blah, blah. But now all we need to do is should have just copy pasted that code, but just need to create the visitor, amount, however much you want to pay, and then have the payment source. So now you can make this payment. All right, so you'll accept even knowing the visitor here. So this method doesn't know the concrete type of this payment source. But since we're using polymorphic approach here, we can just pass in the visitor, have it accept it, and then we know it's going to be taken care of. Yeah, so that kind of shows the power of visitors. So to sum it up, when you want to add operations to a group of concrete classes, this is when you can consider the visitor. So if you're looking through your code and you see a lot of switch statements that switch on concrete type, that indicates that you might want to look at using a visitor. Or if you want to just add operations that really shouldn't be in that class, such as the example we gave here. That's another case where you might want to use a visitor. I want to do one more quick example, actually, and just show a way to write the visitor in a little more elegant way. So let's say that we want to return an image for a payment source. So you could argue that you could just put an image property in the payment source to have an image associated with each payment source. You could do that. In some cases, you might not want to do that. Let's say that you're whatever you're writing. Let's say you want to have a distinction between kind of more front end or UI code, and you want to have that distinction. You want to have a distinction between that code and your model-based code. So in that case, you might not want to add an image to the payment source. So let's assume we're kind of writing an app like that. So in that case, what you could do is you could define a visitor and that visitor would live in your UI or front end layer, and that visitor can get injected into the model and then return an image. So let's call it payment source image visitor. So it'll implement all these three methods, and we can just return yeah, so this function doesn't return a value. So this is another good example because it'll give an example of how to return values from visitors. So how this will work is you'll just have a property that encapsulates whatever you want to return from the visitor. And you'll just set that property in each of these methods. Oops. And actually, jumping back to my last example, I'm realizing that I had the wrong naming here. There. All right, so let's say we want to get an image from a payment source. Actually, that's whatever. So first you need the visitor. And then what you need to do is you need to pass in the visitor to the payment source. And so this visitor will get passed into this payment source visitor, and then it'll have this image property set. So we can get our image by referencing it from the image source, or the image visitor. All right, this code is a little awkward. It's 3 lines to just say, give me the image from this payment source. So to reduce this a bit, what you can do is you can change your accept method here to actually return a reference to the visitor after you pass it in. And you can do this with generics. So generics allow you to define, if you're not familiar with generics, they allow you to define a function or define a type that can vary in a function. So we're basically saying that this type T, it's always going to be a payment source visitor, but its concrete implementation can change. And then we're saying that when we can take in a visitor of type T, and then after we take that in, we can return, this function is going to return a visitor of the same type. And we use a generic here just to define that, hey, this type is going to be the same. The type that's passed in is going to be the same type that's returned. If you just say that it'll accept a payment source and it'll return a payment source, then you won't be able to, when you call this function, the compiler won't know what concrete type of payment source is returned. So you need to use a generic here. And then in these methods here, so these methods will be changed. So it'll be the same signature for these methods. I'll just show this implementation for the bank account, and I won't do it for the other 2 types. So it will get a visitor here, and then after you do the visit, you just return the visitor. We'd have the same implementation for these guys too. And so down here, now, once we call accept, we'll get this image visitor returned. So we can actually just move this method down here. So we'll get this image visitor returned after this method call, and then we can just reference the image from that. Oops. So a little fewer lines there. We can even just pass this in directly, just to make it a 1-line call. So that's a method you can use to reduce some lines of code when you're using the visitor pattern. So that's the visitor pattern. Pretty simple example here. Definitely a powerful pattern if you want to avoid switches on class types, or if you want to add functionality to classes that you want to make sure that they only have a single responsibility. In this case, that single responsibility was just holding data. We didn't want these classes to deal with network calls or deal with front-end logic when it comes with images. So for this approach, or for this example, the visitor pattern is a good approach to solve for that.